In this video we're going to look at quite a common electric fields question. Pause the video now and try this question. So we need to find the point where the resultant electric field is zero. So let's just quickly visualize the problem. So the electric field is doing something like this. We've got two positive fields, so the fields are kind of going towards each other. They will cancel out at some point where the field is zero. So let's pick some point and think the field is going to be going towards it from the left charge and towards it from the right charge. Now the electric field is a vector field, so we could say this charge sees a positive field and a negative field, and the resultant field is zero. So what we can say is the sum of the electric fields at this point equals zero. So if we take the field from the left charge, let's call this Q1, we're going to get K Q1 over R squared. I'm just going to put R1 for now because we don't know what this distance is, and that is going to be minus the field from the other charge, so K, we'll call this one Q2 over R2 squared, because again we don't know what this distance is. We've called that R2, we've called that R1, and that is going to equal 0. So we can rearrange this and we can say K Q1 over R2 1 equals K Q2 over R2 squared. Now we can simplify this in two ways. One, clearly this is just a constant, so that simplifies, that cancels from both sides. Now we've got two different radii here. Now this is not helpful because we've got one equation with two unknowns, so we need to find a way to replace this with a single variable. So let's look at our situation. So we know that the point is somewhere between them. We don't know exactly where it is. So what we can do is we can say the distance from the 5 coulomb charge that we're trying to find is going to be x, and the other distance, well clearly that's the difference between x and 16, so that distance is going to be 16 minus x. So that allows us to replace these two unknowns with a single variable x. So what I can then do is rewrite this as Q1. Now Q1 is obviously this 5 coulomb charge, so I can say Q1 is 5. R1 becomes x squared. Q2 is 20, and R2 becomes 16 minus x all squared. So now it's just a case of solving this equation. So obviously we can expand this out. 5 over x squared is 20 over 256 plus x squared minus 32x. We can obviously rearrange that by cross multiplying. When you do that, you end up with a quadratic that looks like this. So I've obviously skipped out a couple of steps, but I'm sure you can do this without too much difficulty. You then need to solve this quadratic. This is a little bit more complicated than the typical one you'd get in an exam, but you can solve this in any way you want, and you end up with x is 5.3 millimeters. So the distance away from point the 5 coulomb charge, or the 5 nanocoulomb charge, this x here is going to be 5.3 millimeters. So clearly this diagram is not to scale because the x point is going to be much closer to the left hand side.